Hey guys, welcome back. Now let's get started with our day 15 walkthrough. You guys can go ahead and read the story here. Problem statement. Mex Kitty has been tasked with building a spam email detector using ML. She has been provided with a sample dataset collected from different sources to train the machine learning model. Learning objectives. In this task, we will explore different steps in a generic machine learning pipeline, machine learning classification and training models, how to split the dataset into training and testing data, how to prepare the machine learning model, and how to evaluate the model's effectiveness. As we are already familiar with Jupyter Notebook, let's move on. Exploring machine learning pipeline. A machine learning pipeline refers to the series of steps involved in building and deploying an ML model. These steps ensure that data flows efficiently from its raw form to predictions and insights. A typical pipeline would include collecting data from different sources in different forms, processing it and performing feature extraction from the data, splitting the data into testing and training data, and then applying machine learning models and predictions. Step 0. Importing the required libraries. Before starting with data collection, we will import the required libraries. Jupyter Notebook comes with all libraries we need for machine learning. Here we are importing two key libraries, NumPy and Pandas. The libraries are already explained in detail in the previous task. So let's go ahead and fire up our machine. Step 1. Data collection. Data collection is the process of gathering raw data from various sources to be used for machine learning. This data can originate from numerous sources such as databases, text files, APIs, online repositories, sensors, surveys, web scraping, and many others. Here we are using Pandas library to load the data collected from various sources in the CSV format. The dataset contains spam and ham emails. Testing or checking dataset. Let's review the dataset we just imported. The category column contains the email classification and the message column contains the email body as shown below. Data frames provide a structured and tabular representation of the data that's intuitive and easy to read. Using the command below, let's use the Pandas library to convert the data into a frame. It will make the data easy to analyze and manipulate. So if you remember, we have done this in the previous tasks also. Data processing. Data processing refers to the techniques used to convert a raw data into a clean, organized, understandable, and structured format suitable for machine learning. Given that raw data is often messy, inconsistent, and incomplete, pre-processing is an essential step to ensure that the data feeding to the ML models is relevant and of high quality. Here are some common techniques used in data processing: cleaning, normalization, standardization, feature extraction, dimensionality reduction, discretization, text preprocessing, imputation, and feature engineering. Utilizing count vectorizer. Machine learning models understand numbers, not text. This means that the text needs to be transformed into a numerical format. Count vectorizer, a class provided by the scikit-learn library in Python, achieves this by converting the text into a token, count matrix. It is used to prepare the data for machine learning models to use and predict decisions on. Here we are using a count vectorizer function from the sklearn library. So here we are importing the function from the library. Then we are taking a variable vectorizer and calling the function. Then we are using a variable x where a message data frame is converted into numeric format. So this means that for the email in the 0th index, the word in the 77th index has occurred once. Similarly, in the email in the 0th index, the word in the index 401 has occurred once. Similarly, here in the email in the 0th index, the word in the index 2958 has occurred twice. So I hope you guys have understood the numeric representation. Now let's go ahead and follow these steps. So here we have three files. The first one is the email dataset, the second one is the spam detector playground, and the third one is the test emails. So now let's import the libraries that are required. To run these, you have to press Shift plus Enter. Now let's read our dataset. Now let's print the first 5 entries. Now we'll set the data frame. Here we'll import the count vectorizer. And here we'll be converting our message into numeric format. Now let's print it. Step 3. Test or train split dataset. It's important to test the model's performance on unseen data By splitting the data, we can train a model on one subset and test its performance on another. Here the variable x contains the dataset. We will use the functions from the sklearn library to split the dataset into training data and testing data as shown below. So here we are importing the train test split function. So this function will be used to split the data into training data and testing data. And then we are storing the classification data frame into variable y. We have already set the value of x using count vectorizer. So here the test size is equal to 0.2. This means that 20% of the data set will be the testing data and the remaining 80% will be the training data set. Now let's run this. Model training. The next step would be to choose the text classification model and use it to train on the given dataset. Some commonly used text classification models are explained below: naive-Bayes classifier, support vector machine, logistic regression, decision trees, random forest, gradient boosting machines, k-nearest neighbors. Naive-Bayes is a statistical model that uses probability of certain words appearing in spam and non-spam emails to determine whether a new email is spam or not. How naive-Bayes classification works. Let's say we have a bunch of emails, some labeled as spam and others as ham. The naive-Bayes algorithm learns from these emails. It looks for all the words in each email and calculates how frequently each word appears in a spam or ham emails. For instance, words like free, win, offer, and lottery might appear more in spam emails. The naive-Bayes algorithm calculates the probability of the emails being spam based on the word it contains. When the model is trained with naive-Bayes and gets a new email that says, win a free toy now, then it thinks, win often appears in spam, so it increases the chance of the email being a spam. Toy might be neutral, often appearing in both spam and ham. After considering all the words, it calculates the overall probability of the email being a spam or a ham. If the calculated probability of spam is higher than that of ham, the algorithm classifies the email as spam. Otherwise, it is classified as ham. Let's use naive-Bayes to train the model as shown and explained below. So here when we call the fit method, the multinomial NB model goes through the dataset and learns patterns. In the context of naive-Bayes, it calculates the probabilities and likelihood of each feature, word or token being associated with each class, spam or ham. These calculations are based on Bayes' theorem and assumption of the feature independence gives the class label. Once the model has been trained with the fit method, it can be used to make predictions on new unseen data. So let's run this here. Step 5. Model evaluation. After training, it's essential to evaluate the model's performance on the test set to gauge its predictive power. This will give you metrics such as accuracy, precision, and recall. So here we are importing classification report from sklearn.metrics, and here we are providing the X test data and asking it to predict, and here we are printing the classification report. So let's run this here. Testing the model. Once satisfied with the model's performance, we can use it to classify new messages and determine if they are spam or ham. Mex Kitty is happy that a workable spam detector model has been developed. She has provided us with some test emails in the file test_emails.csv and wants us to run the prepared model against the emails to test our model's results. Update the following code to include the test emails file and run the trained model against these emails. So let's go and update this. Since we are using test data here, we have to use the same here. So let's run this. I forgot to put the double quotes here. Let's run this again. So now we have got the predictions from our model on the test data set. Now let's try to answer the questions here. What is the key first step in machine learning pipeline? So that is data collection. Which data preprocessing feature is used to create new features or modify existing ones to improve the model performance? So let's go ahead and check that. So as you can see here, it is feature engineering. During the data splitting step, 20% of the data was split for testing, What is the percentage weightage average of precision of spam detection? Okay, now let's go ahead and check that. Okay, so here we have 0.98. How many of the test emails are marked as spam? So here we have 1, 2, 3. So we have 3. One of the emails that is detected as spam contains a secret code. What is the code? So now we have completed our day 15 walkthrough. Thank you for watching my video and stay tuned for more.